Hello everyone and welcome to Try See Anthropology. I'm Eric and today we'll be talking about how to use 3D models for archaeology. So we're going to be going over how to download models, where to download models, what applications to use to open the models, and then how to do some basic variable measurements like linear measurements. Maybe we want to get some angles in there. We could even get into really sophisticated statistical packages, but we're just going to go over some of the cool things that you can do with 3D models, how it works, and what it's all about. And hopefully that'll help you if you're new to 3D models and archaeology, and if you want to be able to look at artifacts even if you can't physically see them yourself. So first things first is let's talk about where to find those models. So we're going to be using Sketchfab, which is where most people who are making 3D models for archaeology are going to be uploading things. And so when you go to Sketchfab, you'll want to search whatever 3D model you're looking for. The other important thing to keep in mind is that you'll need to have your own account. So you'll need to set up your own Sketchfab account. That's basically, you'll need to confirm with email and all that jazz. Basically, when we go to download download models, you'll want to be able to actually download them, and you won't be able to do that unless you have an account. So we're going to just do BSU AAL. That's Ball State University Applied Anthropology Laboratories, and as you can see, they've uploaded a lot. And they have a lot of good 3D models for us to play around with. So if I just click on one of these right here, it's loading the 3D model. Now, not everyone's going to be like Ball State University. Some people are going to upload things slightly differently. Ball State has their own catalog system, and some of them will have catalog numbers, like you can see right here. It says DO 676, which you can see down here. They tend to put in the projectile point type or the artifact type in general. So we're looking at a stone tool, and I can spin it around and rotate it so I can view it all day long, right? So if I'm just interested in viewing these artifacts, bada bing, bada boom, I've got it right here, right? But we probably want to do a little bit more analysis, thinking like archaeologists. We want to capture some data more than just seeing what's there. And luckily Ball State, for most of their data, allows it to be downloadable. Unfortunately, this one is not downloadable, so we're going to switch really quickly over to this guy right here, which I'm going to be using as our example for today's tutorial. It's called COADS 15632. It's loading that model there. So again, we can spin it around, we can see it. And this was made using a a Next Engine scanner, and then Scan Studio is the software. But to give you a little context for that, basically it was used or scanned on something that looks like this. So, and conveniently, this is already labeled because I helped write the tutorial that this is from, this little manual here. So we've got the scanner right here. The artifact was placed on this stand, and then laser beams were shot out right here at the artifact, and it was rotated 360 degrees and spliced into different segments to merge together to make that 3D model that we're looking at here. Another way that you could get a 3D model, for context on how these are made and why the quality of the model might change from object to object, is through something called photogrammetry. So if we look at this image here, basically what they're doing is the same thing, but instead of having a scanner that rotates the object, we ourselves, the photographers, are rotating, and we're taking all these, sorry, I'm pointing, you can't see, but we're taking all these photos here, and then we're merging them into one solid three-dimensional object, and that's called photogrammetry. So those are two different approaches that you can have to making a 3D model: photogrammetry and 3D scanning. Now, for the ones that we're going to be dealing with, it's mostly going to be 3D scanning, but you will run into people who have done photogrammetry on objects like this barn here. And of course, with all the stuff that I'm referencing, I'm going to be putting links to these in the description below, and hopefully that'll help you navigate to some of these applications. So anyway, let's go back to our example here. So we've got this artifact here that we want to do more analysis with. So we want to go down here. It's going to present me with these options here. So it's going to present me with PLY, which is the original format, and then these other formats here. We don't really want to worry about those other formats because the applications that we're going to be uploading these 3D models into, we're going to hopefully want them, or actually not hopefully, we have to have them in either OBJ or PLY format, object or polygon formats, because of the apps that we're going to be using later. So when we download it, I just saved it to a download location. We're going to do like a cooking show and and pull up a already saved location. So I've saved it in my Ohio Archaeology folder because this is an artifact from Ohio. And there it is right there. It's zipped, coads 15632 right here. And then you don't need to worry about all this cluttered up stuff. And then what I've done is I've extracted it because it's a zipped folder, and you can see I've extracted it down to here. And so then I've got another folder in here, and you'll notice I had to extract it a second time, so I'm not sure. This might be particular to this artifact at Ball State, but again, every person who uploads on Sketchfab is different, so depending on how you extracted the zipped file, you may not have to extract again. But in this case, I had to extract it a second time, and then when I click on this again, here's the 3D object. It's telling me it's a 3D object. If I right click and look at properties, I can see that it is a .ply. If I look right here, if you have a PC, it's going to open in 3D Viewer, which is in, I believe, Windows 10 and newer. 3D Viewer is more for if you want to see what it's going to look like as a 3D printed object. We're not so concerned about that. I suppose if you wanted to print it, you could. And so we can rotate it around. We can look at it. Now it's not going to give us that texture, so it's just giving us grayscale, right? So it's not showing us anything in terms of color or in terms of weird things that are written on it. And I could change the light source if I want to, but we don't really want to work in 3D Viewer because it's more for 3D printing. So we're not going to worry about that. What we are going to open it in is an application called MeshLab. So MeshLab is a freeware application. Should be pretty straightforward to download. When you open it up, I'm actually going to close out of it right now. You're going to be either with the blank screen like this, or you're going to have a purplish background like that. But whatever application you do end up importing in, you're going to be importing that mesh under the file import mesh, and then since I've already done this before, I've already navigated to it, but in your case you'll have to navigate to wherever you saved that downloaded file, and then you'll click on it, click open, and then it will pop it out. Eventually you'll see it down here in the bar. It's loading, pops it out right here. So it's not centered. If I double click on it, it'll take it up here and it'll center it. And so now I can rotate it around and I can look at it and I can see it in all its glory and whatnot. So there's all sorts of things you can do in MeshLab. If you decide you want to go on and do some statistical analysis, like geometric morphometric analysis, so looking at the shape of the object, there's all sorts of things that we can do in the filters to close holes so that it's not it doesn't have any technically holes in it. It's watertight, as we would say. And that's really important for all sorts of later analysis that you might do. We're probably not going to be too concerned with it here since we're just learning the basics. And then we'll want to be able to take some measurements. So there's not a whole lot of measurements you can do in MeshLab. You could get the volume of the object if you wanted to. Now, in the field, people usually aren't gathering volume as an attribute. So usually, or in the lab either, people aren't taking cups of water and putting stone tools in them to get the volume. But it is an option since we can't get the weight because we don't physically have the object in front of us. So it is an alternative variable to collect. But most of the things that you're going to be collecting in MeshLab are going to be linear measurements. So if you go up to the tape measure, you can see up here at the top, and I click on it, it's going to say point-to-point measure. So now if I click up here close to the top, and then I drag it all the way to the bottom or close to it, it's going to give me this linear measurement. And you can see that it's cutting right through the artifact, right? It's because it's not confined to real space. It can go right through the object. Unlike in reality, if I had calipers, I couldn't just put a line straight through the object. But then if we look down here at the bottom, we can see it says M0, so this is measurement 0, is equal to 36.9037. Now what the heck does that mean? This is where it becomes really tricky, and why we're using specifically Ball State's 3D models is because they already had scales built into them, so that when the PLYs were exported, we already knew the scale factor. So in this case, we know that this is in millimeters, so that's 36.9 millimeters in length. So if I wanted that in centimeters, that'd just be 3.69 centimeters, right? And for perspective, I have a little ruler here, so 3.6. Yeah, so it's about, we'd be talking about something about that big. It's not super big, right? Tiny projectile point, because remember, these are going on the end of spear shafts or darts, and they're being thrown with an atlatl, so they're not very big. And so we can do linear measurements. You could get, the maximum length of the object. We could get, shoulder to shoulder. If we know something about lithics, we might have specific linear measurements that we want to capture. And then there's one that's going to be universal or pretty close to it for a lot of objects that we're looking at, whether we're looking at lithics or ceramics. Those are going to be the big two that are going to be 3D scanned right now, especially on Ball State's collection. And that's going to be thickness. So this one is going to be a bit trickier than the other ones to capture, mostly because, oh boy, mostly because you'll see it looks like I'm good at getting a cross section here, but, oh, and it just disappeared. Let's double back to it. But you can see that line is not perfectly bisecting the object. So I'm not actually getting a true thickness measurement. Ideally, I'd want to run it from here to here. But it's really tricky because you're dealing with the three-dimensional object, but you're only looking at it in profile or cross-section view, right? So obviously this measurement's not going to cut it. We're probably going to want to go back and redo this measurement. Now, there's other measurements we could get, not necessarily from Sketchfab or from MeshLab, but we could just get it from observing the object and rotating it. So again, we've got all those different linear measurements that we might think are useful. So for lithics, that might be the ratio of the length of the blade to the stem. So thinking of a pencil as an example here, the eraser head's not going to change. That's going to be fixed regardless of the length of the pencil. But if I continue to use it and I sharpen it, I'm going to be slowly reducing the length of the pencil, right? So this is going to get shorter and shorter and shorter, but the eraser fixture is not going to change through time. So that ratio of the length of the blade to the stem is going to tell us something about how long that object's been used, right? Because it's been resharpened, it's been reworked. So in theory, longer objects or larger or more closer to 1, 1-to-1 ratio might indicate something different based on the artifact type. Obviously, a 1-to-1 ratio for a pencil would mean it's probably pretty short because this is a very, very short eraser fixture area, and this is a very, very long piece of pencil right here. So we'd probably expect for pencils that haven't been used much to be a very large positive ratio, right? Above 1, because this is, many, many times, maybe 5 or 6 times larger than this little eraser point right here. And sorry, that's really far back there for that example. We could also run this in Blender. Now, I'm not very experienced in using 3D models in Blender, but from my understanding, you can do a lot of the same things in Blender. If you're more well-versed in Blender, highly recommend trying out different platforms and different applications. Also free to use. You can use it for video editing as well. Other things you could do, obviously, we want to look at the object and look at the surface treatment. You can't really tell from this scan, but something we might be able to do is if we go to, oh, where is it on here? Oh, okay, here we go, mesh. So we go over to color and we go vertices, mesh, shading. We can get all sorts of different ways of viewing it. So now I've taken all that surface texture off and I can more easily see those flake scars. So how the object was struck by stone and removed other flake scars. So I can see there's one here, a large one here, a little tiny one here. And I might want to start to count the flake scars, or another one right here that's really prominent. And that might start to tell me something about resharpening. So how often has it been struck again and again and again to make it smaller, reducing the size overall to get that new edge. But you can do all sorts of advanced statistics with these 3D models, and there's new applications out there. This one in particular, AGMT3D, which stands for Archaeological Geometric Tools 3D, AGMT3D, yeah. Is a free application that basically puts little landmarks all across your objects to start to map out differences in shape variation and see if you can't find statistical and meaningful differences between this shape versus this shape and if one can morph into the other. Really common in biological sciences, but it's still relatively new to archaeology. But that's also something that if you're really interested in looking at shape variation through time, that we can use these 3D models for using this application here, which again, I will link in the description below. So hopefully that was helpful, useful, and if you liked the content that you saw today, then please consider donating to any of the various charities that are below that I will also link. These organizations make anthropology and anthropologists like myself and the content you're watching possible. So be sure if you enjoyed this or care immensely about anthropology, archaeology, cultural anthropology, linguistics, historic preservation, to consider donating to any of those charities below. And until next time, never stop learning.